We know why machines fail. Things like defective parts, poor assembly, manufacturing errors, operating overload, ageing of parts, parts that are ageing but not replaced, local environment degradation. This is an example of our lubricant. If our lubricant gets water in it, the local environment degrades. If it gets wear particles or dust and dirt, the oil is degraded. And of course, eventually things do age. I'm 57 now, I'm getting tired, my muscles aren't as strong. As the years go by, my hips and my knees are going to cause problems. I'm expecting that because it's going to happen with time. Things will age. What we've found, there's a proportion of parts failures. A lot of our parts fail very early in their service life. Between 50% and 70% fail in this early life failure zone. I define that as a failure from some sort of error. Now, this is a brand new part and it fails. A brand new part fails. Well, it can only fail for one reason. It's been stressed very, very high, very, very early in its life. From our fatigue curve, it must have been stressed hugely very early on. This zone here, this flat zone, is the random failure zone. And this means a situation arises that the stress is induced by some sort of creation. Don't know what that is. There is a reason for it, but that creation and that stress is a random phenomenon. It'll happen at various times. So there will be, across the whole life of a machine, some sort of failures that occur from time to time. Then of course, as it gets older, our parts will fail. So yeah, we understand why they break, understand what causes them to do that. The challenge is now is to prevent that. Now this big curve here, this main curve, is called the rate of occurrence of failure. This is the curve for a machine. This one that's a wobbly line is a single machine. And a single machine, it fails when its parts fail. So this particular wobbly curve here would be a machine. As each part fails, the machine failure rate increases. Here, the failure rate is very, very low. Here it's high. So the higher the failure rate, the more parts that are failing. When I get many of the same machines together, a huge group of those machines, maybe 1,000 of them, we get an average figure. So this dark, thick curve is the average figure of many machines of that same model. What this is trying to say is that my machine fails because the parts fail. If I can prevent the parts from failing, then this curve comes lower and lower and lower, because that curve is a result after the parts break.